Welcome to this lesson on the ideal gas law, one of the most important equations in chemistry and physics. The ideal gas law is represented by the equation PV equals nRT. This master equation describes the behavior of ideal gases by relating four key properties: pressure, volume, amount of gas, and temperature. It combines three fundamental gas laws into one powerful relationship that you can use to solve a wide variety of problems involving gases. Throughout this video, we'll break down each component of this equation and show you how to apply it in real-world situations. Let's examine each variable in the ideal gas law equation. P represents pressure, which is the force exerted by gas molecules colliding with the walls of their container. Pressure is measured in pascals or atmospheres. V stands for volume, which is the amount of space the gas occupies. Volume is typically measured in cubic meters or liters. The letter N represents the amount of gas, measured in moles. 1 mole contains approximately 6.02 times 10 to the power 23 particles, known as Avogadro's number. Finally, T represents temperature, which must always be measured in Kelvin. Temperature in Kelvin equals temperature in Celsius plus 273.15. Understanding these variables is crucial for working with the ideal gas law. The letter R in our equation represents the universal gas constant, a fundamental value that connects all the other variables. The gas constant has different numerical values depending on the units you're using. When working with pressure in pascals and volume in cubic meters, R equals 8.314 joules per mole Kelvin. However, when using pressure in atmospheres and volume in liters, which is more common in chemistry problems, R equals 0.0821 liter atmospheres per mole Kelvin. It's essential to match your R value with the units of your other variables. Using the wrong value of R is a common mistake that leads to incorrect answers. The ideal gas law works best under specific conditions. First, it applies at low pressure, where gas molecules are spread far apart and rarely interact with each other. Second, it's most accurate at high temperature, where molecules move fast enough to overcome any attractive forces between them. Third, the law assumes no intermolecular forces exist, meaning molecules don't attract or repel one another. Finally, it assumes the volume of the gas molecules themselves is negligible compared to the container volume. Real gases behave most like ideal gases under these conditions. At very high pressures or very low temperatures, real gases deviate from ideal behavior and more complex equations are needed. For most everyday situations and typical laboratory conditions, the ideal gas law provides excellent approximations. The ideal gas law can be rearranged to solve for any of the four variables. If you need to find pressure, rearrange the equation to P equals nRT divided by V to find volume. Use V equals nRT divided by P if you're looking for the number of moles. The equation becomes N equals PV divided by RT, and to calculate temperature, rearrange it to T equals PV divided by NR. The key is to identify which variable you're solving for and which three variables you already know. Always write down your known values first, choose the appropriate form of R, and then substitute your values into the rearranged equation. This systematic approach will help you solve any ideal gas law problem. Let's work through a practical example. Calculate the pressure of 2 moles of gas in a 10-liter container at 300 Kelvin. First, identify what we know. We have N equals 2 moles, V equals 10 liters, and T equals 300 Kelvin. We need to find the pressure P. Since we're using liters for volume, we'll use R equals 0.0821 liter atmospheres per mole Kelvin. Our answer will be in atmospheres. Now we're ready to substitute these values into the equation and calculate the pressure. Here's how we solve the problem step by step. Step 1. Use the formula P equals nRT divided by V. Step 2. Substitute the values. P equals 2 times 0.0821 times 300, all divided by 10. Step 3. Calculate. First multiply 2 times 0.0821 times 300, which equals 49.26. Then divide 49.26 by 10, which equals 4.926 atmospheres. Rounding to 3 significant figures, our final answer is P equals 4.93 atmospheres. This means the gas exerts a pressure of nearly 5 atmospheres on the container walls. Always remember to include units in your final answer and round appropriately based on the precision of your given values. Let's review the most important points about the ideal gas law. First, it combines all 3 individual gas laws, Boyle's law, Charles's law, and Avogadro's law, into one comprehensive master equation. This makes it incredibly powerful for solving gas problems. Second, always convert temperature to Kelvin before calculating. Using Celsius or Fahrenheit will give you completely incorrect results. Third, remember that the ideal gas law works best for ideal gases at low pressure and high temperature. Under extreme conditions, you may need to use more complex equations. The equation PV equals nRT is your essential tool for understanding and predicting gas behavior in chemistry and physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.